So let's jump right into a thought experiment that is, well, just as terrifying as it is fascinating. What would actually happen if the single most important force shaping our entire universe just disappeared?
I mean it. Imagine you're just sitting there, listening to this. What if, in this exact instant, the invisible force holding you to your chair and your chair to the floor and the earth to the sun just stopped?
Yeah, we're not talking about some slow, gradual fade. No, we're talking about flipping a cosmic switch. Poof! The fundamental rule that governs everything from a falling apple to an orbiting galaxy is suddenly gone. The consequences? They'd be immediate and they'd be absolute.
Okay, so before we completely break the universe, let's take a second to really appreciate what we're about to lose. What is gravity, really, and what is it doing for us every single second of every single day? You can think of gravity as the universe's master architect. Now, it's actually the weakest of the four fundamental forces, which is kind of surprising. But over huge distances, its influence is totally unmatched. It's this silent, persistent force that sculpted basically everything we see out there in the cosmos.
And its job description is, well, it's pretty impressive. On a personal level, it's what keeps our feet on the ground. On a planetary scale, it's what's holding on to our precious atmosphere and all of our oceans. And then, on a cosmic scale, it's the director of this grand celestial ballet, right? It choreographs the orbits of planets and stars and entire galaxies. Without it, none of this beautiful structure would even exist.
All right, we've given gravity its due. Now, let's switch it off. What happens in those first few moments? The answer is just pure, unadulterated chaos.
The very moment gravity vanishes, anything not physically bolted to the planet's bedrock would just begin to drift away. You, your car, the water in the oceans, all of it would start floating upwards. A minute or two later, the air you're breathing, it would follow, just bleeding out into the void. In less time than it takes to brew a pot of coffee, Earth would be stripped of its atmosphere, becoming a silent, airless rock.
Now get a load of this number, 1,600 kilometers per hour. That is how fast the Earth is spinning at the equator. And gravity is the only thing keeping us attached to that wild ride. Without it, another powerful law of physics takes over, inertia.
That's right, because of inertia, everything on the surface would just keep moving in a straight line, flying off the spinning Earth like a stone from a sling. So we wouldn't just float up, oh no, we would be hurled into the darkness in this catastrophic planetary exodus.
And this right here, this just illustrates the grim reality for any human caught in this scenario. As our atmosphere vanishes, the vacuum of space takes over. The oxygen in your blood would literally be stripped away through your lungs, and without it, your brain would just shut down in less than 15 seconds.
But this isn't just a planetary disaster, it's a full-on cosmic one. The chaos wouldn't be limited to just Earth. With gravity gone, the entire architecture of the universe itself would begin to crumble.
You're looking at a cosmic cascade failure. First, Earth flies away, no longer bound to the sun, just shooting off into space at nearly 30 kilometers per second. Next, all the other planets go rogue, abandoning their orbits and completely dissolving the solar system. But it gets so much worse. Even planets like Earth would begin to break apart, since there's nothing holding them together anymore. And the most spectacular event? The stars would explode. Without gravity to contain their immense energy, every single star basically becomes a bomb. And finally, entire galaxies would just dissolve, unraveling the whole cosmos into a chaotic soup of gas and dust.
Wow, that was bleak. So the good news is this can't actually happen. Let's pivot from this disaster movie scenario and look at the real physics that makes gravity a permanent, unshakable feature of our reality. So, is there some kind of cosmic off switch we just don't know about? Well, the short answer is a definitive no. And the reason why lies in what gravity actually is. But here's a surprise. You wouldn't fly apart into a cloud of atoms. Why not? Because the force holding your molecules together, electromagnetism, is just ludicrously powerful. We're talking 10 to the 38 times stronger than gravity. See, electromagnetism rules the small scale, but on the grand cosmic scale, gravity's incredible reach makes it the only force that really matters for holding big things together. And here's the crucial point. Gravity isn't a force that can be turned on or off. As Einstein showed us, gravity is the shape of the universe. It's the warping of space-time that's caused by mass and energy. So as long as matter exists, space-time's going to be curved, and gravity will be there. To get rid of gravity, you'd literally have to get rid of the universe itself. So after this whirlwind tour of cosmic destruction, what's the big takeaway from our little thought experiment? What's the point of it all?
It's this. This gentle, almost imperceptible force is responsible for everything. It allowed the first particles to clump together after the Big Bang, which formed the first stars. It built the galaxies, it forged the planets, and ultimately, it created the very conditions for life to emerge. Plain and simple. We exist because gravity exists.
So the next time you take a step, just remember the immense, invisible power at work. Gravity keeps us grounded here, but our own curiosity drives us to try and escape it. And as any astronaut will tell you, even temporarily leaving its full embrace challenges our bodies in really profound ways, reminding us that we are creatures fundamentally shaped by this incredible, essential force.